All right, y'all. You want to work through some of the free response for? We've done that some in class, but we haven't done it a whole lot. Is this on? Testing, testing. So the free response will look a lot like previous free response questions, except for you're not going to have a multi-loop circuit. And so as I said in class, instead of that third question being a multi-loop circuit, it's going to be one like this, where you have, I give you some material, I say this material is copper, or it's tungsten, or it's whatever, silver or gold, and I give you the dimensions. I give you the length, say is, I don't know, 0.5 meters, and the radius is 0.1 meters, or whatever, and you have to calculate the area. And then once you do that, then you can solve for the resistance of that material. And then I'll say, well, what if you apply a certain voltage, 6 volts, for example? That's not what it's going to be. I don't know what it is. But if I apply 6 volts, then what is the power that is dissipated across that material? Okay, so that'll be one question. Actually, be 2 questions on your free response. And then you'll have 6 questions that'll come from circuits. One of these will be a capacitor circuit. I drew this in class, but that's sort of the first hurdle, is to take this circuit and make it into this circuit. All right. I find that comes with practice. I can show you. I tried to show you in class on yesterday how you can take these 3 points right here and condense them down to this point. You see, because there's no devices in between those points, they're the same electrically. So if I have a wire right here, I have 2 points on this wire. Electrically, this point is identical to this point. The potential is the same for both of these points because there's no batteries or resistors in between. And that's true on this circuit too, that I can condense all 3 of those points down into one. And then I get a circuit that looks a lot like this one. So once I get this, then I begin making that circuit simpler and simpler. I see that I have two 2 microfarad capacitors in series, 1 over 1 over 2 plus 1 over 2. That's equal to 1 microfarad. And then I have a 3 and a 6 microfarad. That's 2 microfarads. 1 over 3 plus 1 over 6 is 2. And then I can begin combining those. So now my circuit simplifies to just 2 capacitors that are 2 microfarads, because I combine this one with this 1 microfarad, and then 1 plus 2 plus 1 plus 2 plus 1, which is 4 microfarads. And then I have this all over 12 volts. Now, once I get this, there are a couple ways that I can go about determining the voltage on each of those capacitors. I think the easiest way, and the way that I really prefer you to do it, is to say that I have 2 capacitors, one big, one small. One's bigger by a factor of 2, so that means that the voltages have to add up to equal to 12, and one has to be bigger than the other one by a factor of 2. We've done this a bunch of times in class, right? So which one is going to have the bigger voltage? The 2 microfarad, and it's going to have a voltage of 8 volts. So I have 8 volts here, 4 volts here. However, if you don't remember how to do it that way, you can find the equivalent resistance, although in this one it becomes a little more difficult because the 2 and the 4 don't add up evenly. 1 over 2 plus 1 over 4, that's 2/4 plus 1/4, which is 3/4, and the inverse of that is 4/3 microfarads. Then I have a circuit that is 12 volts with 4/3 microfarads. It has a charge of 12 times 4/3, which is 16 microcoulombs. So I know that this capacitor has 16 microcoulombs, and this one also has 16 microcoulombs. Then I can find the voltage, which is Q divided by C. 16 divided by 4 is equal to 4. 16 divided by 2 is equal to 8. At this point, we can probably go back and begin answering questions. So What is the equivalent capacitance? Well, I've already found that. That was the 4/3 microfarads. What is the charge on C4? C4 is this capacitor right here. What is the voltage on that capacitor? Well, I know that the voltage here is 4 volts and the voltage here is 8 volts. That means that I have 4 volts on this section and 8 volts across this section. So the voltage on that 1 microfarad capacitor is 4 volts. I have 4 volts here. So that's the charge then is 4 times 1, or 4 microcoulombs. And then the voltage on C6. See, C6 is this capacitor. Well, I know that I have 8 volts here, and then I have 8 volts across both of these capacitors. So that voltage is going to be, what, do you know? 4, right, because 2 identical capacitors will split that voltage evenly. That's true for resistors too, so I have 4 volts there. Okay, I do have some new numbers on this exam. I don't know, I was just sort of feeling, what did they say? Feeling cute, is that what they say? I came up with some new numbers to use for our inverses. So I just want to recognize that 1 over 1 over 8 plus 1 over 8, what does that equal to? That's equal to 4. I think I did 9 too. 1 over 9 plus 1 over 9 plus 1 over 9. What does that equal to? That's 1 over 3/9, which is 1 over 1/3, which is equal to 3. Okay, so those are just some other combinations of numbers. We've seen some others as well, like I think 1, 2, and 6. Is that right? 1 over 2. 1 over 1 plus 1 over 6. That's 3, 6. No, it must be 3. 2. Yeah. Do y'all know what 2, 3, and 6 is? That's equal to 1. Yeah, so those are some other common numbers, although I don't think I've ever used the 8s. I've used the 9s before. But I don't want y'all to get stumbled on the numbers. Just, you can write those down, make sure you sort of are familiar with them. You can always do it in your calculator. Yeah.
So, where did the 4 and 2 come from on the, like when you had like the 8 volts and the 4 volts?
Mm-hmm.
Where did, earlier you had like.
Yeah, you're talking, I think, about, let me see, about this 4 and this 2?
Yes.
Yeah, so the 4 came from 1 plus 2 plus 1. Because I had a 1, these, let me redraw it.
I
1, 2, and 1. Yeah, be careful because you know the rules switch for resistors and capacitors. Yeah, so when you shift from capacitors to resistors, make sure that you're shifting into that other thoughts. Yeah, okay.
For part B, whenever you're trying to find the charge, is it always just sharing 4 volts? It just becomes 4.
No, so yeah. Yeah, for part B, that was, just to remind you, I should have said that right here, this one. I know that it has 4 volts, and look, it's 1 microfarad, so Q is equal to C times V. It just happened that C was equal to 1 and V was equal to 4, so it became 4 microcoulombs. All right? Y'all okay with those circuits? Mm-hmm. First one on spring of 21. It's a similar, I think it's a capacitor problem, right? Oh, did I? I probably changed them to make it easier. This one? Yeah, I would change the numbers on this one. What did I change them to? You know what I changed them to?
Well, the video, they had other numbers. You said you were going to
Okay. Oh, really? Yeah. Then we just work it in as it is shown. 3, 2, and 1. Yeah. So yeah, this is a good one. So first of all, I want to redraw it. That's sort of the hard part, because when I come up to this junction, I want to know how many branches are in that circuit. I see that there's clearly one, at least one, and then there has to be a second, right? This one right here. But notice that there's also a third branch right there, that I can redraw that circuit so that I have 3 branches in it, where I have a 3 microfarad right here. I have a 2 microfarad here, and I have a 2 microfarad here, and another 2 microfarad here, actually. That's sort of the hard part, is figuring out that these circuits are the same. And then I can redraw that, or keep going, and I have C5, which is 3 microfarads. So let me step through this first of all. So I come to this point, and I see, well, I know there are at least 2 junctions, but I see this point, I can sort of collapse that all down to 1, right, electrically identical. So I have now 3 branches. I have 1 here, and then 1 here. And then I also do this funky thing where they come back together there. But I need you to realize that it doesn't matter. I can move this far all the way down here if I want, and it would still be the same circuit. That is, I could redraw it so that it looks like this, and all coming back together. All right. So when I draw that final circuit, it looks like this one. Now I can combine some of these. I know the 2 and the 2 is 1 microfarad. And then I get a circuit that has 12-volt battery with a 6 microfarad capacitor, 3 plus 2 plus 1, and a 3 microfarad capacitor. So coming back to that combination that we like, 12 volts. Here, I could find the equivalent capacitance. I might have asked that for you. Yeah, the equivalent capacitance would be 2 microfarads. 1 over 6 plus 1 over 3 is equal to 2 microfarads. Then I could find the charge on that. That would be 24 microcoulombs. That's equal to C times V. So I have 24 microcoulombs here, 24 microcoulombs here. So 24 divided by 6 is equal to 4 volts. 24 divided by 3 is equal to 8 volts. Okay, so now that I have those voltages, I can go back and begin putting them in. I have 8 volts here, 4 volts here, 4 volts here, and then these are 2 identical capacitors, so they're each going to have 2 volts and 2 volts. So I just sort of do that without even looking at the questions, but then I can go back and look at the questions. What is the charge on C2? C2 is this capacitor, which is the same as this capacitor. We'll have 4 volts over 2 microfarads. 4 times 2 is 8 microcoulombs. Then what is the voltage on C3? C3 is this capacitor. I had it right here. That's 2 volts. And then the equivalent capacitance is 2 microfarads. I found that down here. I just changed those numbers so that it would work out easier. I try to do that. It doesn't mean that all of your circuits are going to have integer values, but I think maybe all of them do. I'm not sure. Don't take that. I don't know if that's true or not. Okay, we do a resistor circuit too. Practice these, y'all. Practice, practice, practice. Your circuit will look similar to this. I think yours does have a couple more resistors, but it'll be similar. It'll sort of be more traditional format, the way that we draw it. So you won't have to do any of that reconfiguring of the circuit. More like what we've seen in other more traditional ways. So first I find my equivalent. This is 6 ohms. And then a 6 and 3 in series combined. A 6 and 3 in parallel is 2 ohms, and then a 2 and 2 is 1 ohm. So I can redraw this. has a 1 ohm and a 2 ohm. Please stop me if that doesn't make sense to you, because I know that it might not. So here, to get the 1, I did 1 over a half plus a half. 1 over a half plus half is equal to 1. So 1 over 1 is 1. And then here, I had the 2 plus 4 to find the series. I just say 2 plus 4 is 6. And then 6 and 3, that's 1 over 6 plus 1 over 3. That's equal to 2. So I have a 1 and a 2 ohm with 12 volts. Then those combine to give me a 3 ohm with 12 volts. And now I can start stepping back. That means that my current is V over R, 12 over 3, or 4 amps. That means I have 4 amps going through both of those resistors, but V is equal to I times R. So that means I have 4 volts and 8 volts, which jives with what I think it should be, right? Because I should have 2 voltages that add up equal to 12. The small one should have the small voltage. The big one should have the big voltage. Remember, that's different for capacitors. And they're different by a factor of 2, just like the resistors are different. Then I have 4 volts here, 4 volts here, 8 volts here, and R3 and R4. Oh, I do ask that. Ooh, okay. So I have 8 volts across these 2 resistors. I'm going to take that and draw it over here. It says 2 ohms, 4 ohms, and I imagine that across both of them, I have 8 volts across both of those. It splits that 8 volts, but it doesn't split it evenly, right? So I have to figure out what is the current in that circuit. Well, that's a 6 ohm resistor with 8 volts. That means that I is equal to 8 over 6, or 4/3 amps. This has 4/3 amps. This has 4/3 amps. That means I have 8/3 volts and 16/3 volts. But recognize 8 plus 16 is 24, divided by 3 is equal to 8. So those do add up to equal to, they add up to equal to 8 volts. So that just checks that they are what they should be. So R3 has 8/3 volts. 8/3 for A, and then the current through R5 is going to be, well, I is V over R, or 8 divided by 3 amps. Okay? Yeah, you can use decimals. That's fine. I'll accept either. Some of y'all will, some of you won't. I really don't like to have fractions, but sometimes they sneak in there. Okay, y'all? I feel okay with those circuits? Yeah? In the multiple choice, you'll have simpler circuits. So the most difficult circuits will be on the free response, which is where you get partial credit.
Wait, where did it turn into 4 over 3 for the amps?
Yeah, that's tricky, isn't it? So in this little section, this is the hardest part of circuits, is finding the voltage across 2 resistors or capacitors, especially when they're not even. I can't just say, oh, this is 8 and 4 or 6 and 3 or whatever. So what I have to do is find the equivalent resistance, which is what I did right here, and then calculate the current that is going through that equivalent resistance. So I is equal to V over R, which is 8 divided by 6, 8 volts over 6 ohms, which is 4/3 amps. So that 4/3 is the current through this resistor, but it's also the current through this resistor and this resistor. So now when I get the resistance and the current, I do 2V is equal to IR. 4/3 amps times 2 is 8/3. 4/3 amps times 4 is 16/3. Okay? That's probably, we don't do that very often because I try to give you problems where you're just splitting up that voltage more easily so you don't have to go through all the math. But I think there might be 1 or 2 problems where you do need to do that on the exam.
But the 8/3 and 16/3, it's just like checking to make sure you have the right voltage.
Well, no, because I wanted to know what is the voltage across this resistor, which is this voltage right here. That's what I was drawing over here, that this 2 ohm resistor right here is the same as this resistor. That's what I wanted to know. I know I'm not the neatest person in the world, but those of you that are neater than other students, you will benefit because you'll just be able to keep track of your numbers more easily. So even if you're not a real neat person, just try to be very careful and meticulous about, drawing the diagrams. Look, you're pretty neat. Drawing the diagrams and writing down the numbers and just being meticulous and careful in that. Okay? Everybody can be neat, I think, right? Even me? Yeah, maybe not. All right. What particular questions you want to look at?
Do you have any questions that would help us with the third constructive response?
Yeah, sure. I mean, this one, I think actually you have a question that's similar to this in the multiple choice, but this one is somewhat similar where I have to find the resistivity. I'm just really using this equation, R equals rho L over A, and then substituting the values for rho, L, and A. Although in this one you had to solve for what is rho, which is RA over L, just solving that equation for rho. And when you do that, then you find what is the resistivity. Let me see if there's another question, though, where we're actually solving for the resistance. I know there are some in the workbook and also in the homework. Don't usually ask that question. Yeah, see, I usually ask this question where you're identifying the resistivity. Oh, I'm not sure I've seen any. Let's look though. I think maybe number 14 on 20. No, see, that's a similar thing where I have to solve for the resistivity, but I'm going to have you find the resistance. Give me just a second. Okay, let's look in your workbook. I'm pretty sure there's a homework problem that's similar to what you'll see on your free response. If not, I can just make up one and we can work through it. How y'all feeling about the exam? Nervous? Well, no? Good. No? Good. I like to hear. Well, maybe I don't have any. All right, let's just make up one, okay? So this is going to be your third free response. Pick a space. I'll tell you that the length of a wire, the length is, I don't know, let's just say 0.25 meters. That the radius of that wire is 0.002 meters, and the material, let's just say it's gold. And in that case, I should refer you back to this chart. And so when you refer back to that chart, I find that the resistivity is that 2.44 times 10 to the minus 8. That's in ohm meters. And then I ask you two questions. I ask you first, what is the resistance? Now, the first thing you need to do is to figure out what is the area. So the question would say, you have a gold wire that has a length of 0.25 meters, a radius of 0.002 meters. What is the resistance? That's almost exactly what the text says. And so first you find the area. The area is equal to pi times r squared. So the area of this wire is going to be pi times 0.002 squared. And I get 1.26 times 10 to the negative 5. That's in square meters. Now I find the resistance is going to be rho L over A, 2.44 times 10 to the minus 8. L was 0.25 meters, so it's about yay long. And then the area is 1.26 times 10 to the minus 5 square meters. And then I can solve that for the resistance. I get 4.8 times 10 to the minus 4. Know what y'all got? You get that up to you. And that's in ohms. So that would be one answer to it. What is the resistance of this wire? It's pretty small, although wires tend to have a resistance of an ohm or so. We saw that in lab this week. And gold, I guess, has a much lower resistivity. Anyway, the next question that I would ask is, what is the power dissipated? I would say that it has a voltage, I don't know, 12 volts across it. What is the power dissipated? And the way I intend you to do that, there are a couple ways you can go about it, but the easiest way is to say that the power is equal to V squared over R. That's going to be 12 squared divided by that 4.8 times 10 to the minus 4. So that's I get 300,000 watts. Like 0.3 megawatts. Okay? That's your third for your response. I could do that, right? Don't shake your head. No, you can do it. Right? Yeah, good. It's just plugging in numbers, really. Just remember, you need to calculate your area. I give you the radius. Okay? Yeah, you'll have one, I'm pretty sure. I give it on every test, like number 14. But in this case, you have to solve for the resistivity, and you find whatever the resistivity is, and then you go through this table and figure out what is the material. Okay?
The only equation on that whole problem is that we have to know the area. Right?
Yeah, I give you all the other stuff, but I do expect you to know the area of a circle. I think you do, right? Pi r squared. All right? We good then? Okay. All right, let's stop then. If you have more questions, you can come see me afterwards.